You know, we count on computers for just about everything. And a lot of the time, we need them to be random, right? For games, for security, for science. But here's the thing. There's this wild contradiction right at the core of how they work. So let's get into it.
And that's really the big puzzle, isn't it? How can a machine that's built to be perfectly predictable, a machine that follows instructions to the absolute letter, how can that create something that's supposed to be completely unpredictable? It sounds impossible, like a total paradox. But don't worry, we're going to crack it.
Okay, so it all boils down to this one word, deterministic. That's a computer's superpower, right? You put something in, you get the exact same thing out every single time. You hit the A key, you get an A on the screen. It's that reliability that makes them so powerful, but that's the exact opposite of being random.
So if they're not really random, how do they fake it? Well, it turns out they use this incredibly clever trick. It's like a mathematical magic show. Let's pull back the curtain and take a look at something called pseudo-random number generators, or, as we'll call them, PRNGs. Think of a PRNG as just a fancy recipe. It needs one key ingredient to start, which we call a seed. You give it that seed, and the algorithm, the recipe, follows a bunch of steps to cook up this long list of numbers. And yeah, to us, it looks totally random. But here's the secret sauce. If you know the recipe and you know that starting seed, it's not random at all. It's a simulation, a really, really good one. And you'd probably be surprised at how simple this recipe can be, especially the early ones. What you're seeing here is a classic called a Linear Congruential Generator. It's super straightforward. You start with your seed, you multiply it by one number, add another, do a quick bit of math called a modulus, and bang, you've got your first random number. And the best part? That new number becomes the seed for the next one. It's just a simple, predictable loop over and over again.
All right, let's see this in action. Let's say we tell our program, hey, your starting seed is the number 42. Okay, we've given it its starting orders.
And what does it spit back out? Well, it gives us this sequence: 81, 14, 3, 94, 35. Looks random, right? But here's where the magic trick is revealed.
If you change the seed, yeah, you'll get a totally different sequence. But if you use that same seed, that same number 42, you will get the exact same sequence of numbers every single time. It is a perfect, repeatable illusion, and it's all controlled by that one little number you start with.
Okay, so if this is all just a mathematical illusion, does it really matter how good the illusion is? Oh, you bet it does. Because not all of these tricks are created equal, not by a long shot. So one of the main ways we measure how good a generator is by its period. And that's just a fancy word for how long the sequence of numbers gets before it has to start repeating itself. That simple LCG we looked at, it has a pretty short period. It'll start looping back on itself fairly quickly. But then you have modern beasts like the Mersenne Twister, and its period is just, well, it's astronomically long.
Just how long are we talking? The Mersenne Twister's period is 2 to the power of 19,937 minus 1. Let me try to put that into perspective for you. That number is so gigantic, it has more digits in it than there are atoms in the entire known universe. So, yeah, for all practical purposes, you are never going to see that sequence repeat.
So that's it. We're done, right? We've got this generator with a practically infinite sequence. It's got to be perfect for everything, from building levels in a video game to creating top-secret encryption keys. Case closed. But you know there's a catch, right? There's always a catch. And here it is, the big one. Even with that insane period, the Mersenne Twister is still just a recipe. A very complex one, sure, but still a recipe. And it turns out, if someone can see just, get this, around 624 of the numbers it spits out, they can figure out the entire recipe. They can reverse engineer its internal state and predict every single number that will ever come out of it from that point on.
And that predictability is where this stops being a neat trick and starts getting really, really dangerous. Look, for a video game, who cares, right? But for anything related to security, we're talking passwords, encryption keys, bank transactions, predictable is the last word you ever want to hear. The illusion just isn't good enough anymore. We need something real.
So when the stakes are this high, you need a whole different class of tool. And this is where the hero of our story comes in, the cryptographically secure pseudo-random number generator. Let's call it a CSPRNG. And its whole superpower is that it's designed to be unpredictable. Even if an attacker sees a bunch of its output, they have no clue what's coming next. So how on earth does it pull that off? Well, the secret ingredient is a fantastic concept called entropy. Instead of starting with a clean, predictable number like 42 for its seed, a CSPRNG goes out and collects randomness from the real world, from the actual chaos happening on your computer. We're talking about the tiny, unpredictable jitters in your mouse movements, the exact microseconds between your keystrokes, even the faint electrical noise from your computer's chips. It gathers all that chaotic data into a pool of genuine, real-world randomness to use as its seed. And there's this amazing, almost poetic example of this in the real world. The company Cloudflare, which helps secure a huge part of the internet, has a wall of lava lamps in their office, a literal wall of them. And they have a camera pointed at it, constantly recording the gooey, chaotic, unpredictable motion of the lava. That visual chaos is then fed into their systems as a source of entropy. They are literally turning lava lamps into internet security. How cool is that?
All right, so we've basically got two big families of randomness, right? The fast, repeatable illusion, and the genuinely unpredictable stuff that's seeded with real chaos. So let's put it all together and see how this actually plays out in the real world.
This table really lays it all out nicely. You've got your simple, predictable guys like the LCG, good for simple simulations and not much else. Then you've got the workhorse, the Mersenne Twister. It's predictable, sure, but it's perfect for things like video games or data science, where you need something that feels random but is also fast and repeatable. But then, when you get to the serious stuff, security, passwords, tokens, it's a hard stop. You have to use a non-predictable CSPRNG. And that TRNG at the bottom, the true random number generator, that's the source, the physical hardware that's collecting the entropy to get the whole secure process started. And here's why this isn't just academic. It matters a lot. Let's say a developer is lazy and uses a basic random function to generate your forgot password link. A determined attacker could actually have a shot at guessing that link. But if the developer does it the right way and uses a proper cryptographic generator, that link is impossible to predict. It's literally the difference between putting a screen door on a bank vault versus a solid steel one. So at the end of the day, here's the big takeaway. You have to use the right tool for the right job. It's that simple. If you need something to be fast and repeatable, like, say, you're making a game and you want players to be able to share a seed to play the exact same level, then a regular PRNG is your go-to. But if you need unpredictability, if security is on the line, then it's not a choice. You have to use a CSPRNG.
And now you're in on the secret. So the next time some security program pops up and asks you to wiggle your mouse around to generate a key, you'll know exactly what's going on. You're not just killing time. You are the lava lamp. Your own little chaotic movements are becoming the entropy that makes the whole system secure. You're part of the process.
So I'll leave you with this. We see the word random everywhere online. But now, the next time you see it, maybe you'll just pause for a second and you'll ask yourself, is this the cheap magic trick, the fast, repeatable illusion? Or is this the real deal, the unpredictable, chaotic, secure stuff? Because as we've seen, the answer to that question matters a whole lot more than most people realize.